Welcome to my talk on CloudPush, smart delivery of push notification to secure multi-user support for IoT devices. I am Shamsul Arifin presenting this research that's supervised by Dr. Abdullah Adnan from Bangladesh University of Engineering and Technology, and the research is funded by Samsung R&D Institute, Bangladesh. This is the outline of my presentation. Initially, I will describe the overview, motivation, and problem definition. After that, I will describe related works, research objectives, research output, and research challenges. Then I will show experimental setup and results. Finally, I will explain the summary and future work. Internet of Things with a cloud server has become popular nowadays, and it is going to be used in almost every aspect of human life. All devices will be connected to the internet and can communicate with each other, where cloud plays an important role in the IoT environment. Many IoT platforms are being developed by giant companies like Apple, Intel, Cisco, Amazon, Samsung. These are the most popular existing IoT frameworks: IoT, Google Cloud, AWS IoT, Microsoft Azure IoT, Person IoT. Our first motivation is unavailability of simultaneous multi-user support in the existing IoT framework. In this picture, we see that a client app or a smartphone can have two users, user 1 and user 2. So, user 1 and user 2 both can control the same IoT device, and this is called multi-user feature. Moreover, in the underdeveloped or developing countries, many families cannot afford to buy more than one smartphone. With the multi-user feature, different users can control IoT devices with a single smartphone. Our second motivation is the slow cloud response time of IoT framework. IoT framework is an open source project hosted by the Linux Foundation. It creates a standard by which IoT resources and different client devices connect to each other through the internet. IoT server updates resource state as an event, and IoT client work as an observer to get notification of a resource change through IoT cloud. The limitation of the existing IoT frameworks are currently simultaneous multi-user support is not available. Vulnerabilities may arise while supporting multi-user feature, and lack of efficient push message processing cloud service. So we propose a new framework that will overcome these limitations. Related works. Many IoT projects are being developed nowadays, and this technology is very affordable to the general people, but the solution don't have multi-user support in a heterogeneous environment. Activity notification service. Currently, it is possible to observe the resources in activity-based framework to receive notification when attribute values have changed. Activity notification service can utilize caching and monitoring features from activity resource. It can support having all necessary attributes to enable notification service so that device vendors can use same to generate notification and for smart devices to process and understand these notifications. We'll focus here device to server notification. When the consumer finds the notification resource through IoT cloud interface, consumers could make the observe request to the notification provider via IoT cloud. IoT performance. In paper on evaluating IoT cloud platform, evaluates the performance of IoT platform. The work in this paper is our inspiration to evaluate the performance of the CloudPush framework and compare output with IoT platform. Push messaging security problem and its countermeasures are discussed in paper Understanding and Mitigating Security Hazard in Mobile Push Messaging Service. They have revealed significant security flaws in push messaging service that affect billions of mobile users. Hacker can steal sensitive messages from a target device by using push messaging service GCM and fully take control of the device. Cloud in between client device and push messaging service make the whole system security vulnerable. They figure out that weak cloud-side access control and extensive use of pending intent cause some application and system service like PayPal, Facebook, Skype vulnerable and leak out user information while communicating with those apps. They solve the problem by restricted use of pending intent in Android application and creation of refresh token in client side. We'll consider this solution to define our new architecture. Average cost of performing encryption and decryption on mobile device is shown here. Existing network security protocol is not enough. There are many security solutions available for a hybrid network of the internet. This security solution cannot directly be used in the IoT system. So our research objectives are to introduce a smart IoT push messaging framework with multi-user support and design an efficient and improved searching algorithm for faster searching in the cloud database in runtime and find out the vulnerabilities and its solution and to evaluate the performance of CloudPush framework and IoT framework. Our research outputs are a smart push messaging framework named CloudPush. CloudPush framework achieves improved multi-user support push messaging than IoT framework, which will be shown by comparing system performance. Then an efficient searching algorithm in cloud will be developed, and the solution of potential vulnerabilities that arise implementing CloudPush framework. And CloudPush framework achieves better aggregated throughput than IoT framework, which is shown with extensive experimentation and improved CloudPush functionality. The purpose of our IoT push messaging framework is to maintain a communication between IoT resource and a user where IoT resource inform a user if an event occurs at its end through cloud servers. The IoT push messaging framework supports communication among multi-user and multi-accounts of a single user with an IoT device. It consists of an client application, IoT device, and cloud servers. Firstly, client application performs log into the account with an account ID and password, then register IoT device in cloud, and after that receive notification message sent by IoT device through cloud. Cloud supports notification message to enable a client to be notified of desired state of one or more resources in an asynchronous manner. So cloud performs are number one, completes account verification process and inform client application whether account information is valid or not, maintains cloud table and perform database CRUD operation, passes push message to push message service, and response accordingly with the request of client application and IoT device. So through this, IoT device mainly generates events to inform corresponding client mobile device through cloud. Notification message parameters are unique identifier of client and IoT device, then timestamp. So in previous slide I have already discussed this algorithm. Um, the difference between CloudPush and IoT notification framework is shown here. In CloudPush framework, a client device can register an IoT device n times with n number of accounts in cloud, where in IoT framework it is not possible. So while implementing multi-user feature in the deployment of the proposed framework, we figured out three vulnerabilities that can leak information to outsider. Client application receives unintended and unauthorized notification message through cloud from IoT device. As a result, user sensitive data can be exposed by others. So vulnerability 1. As CloudPush framework support multi-user feature, a single client application can use multiple accounts in its device. For a client, only one account ID is active at a time. Client application should receive only the notification from IoT device that are registered with this account ID. Other registered account then current should not get notification message triggered by IoT device. The issue of client applications current login account ID is not related to IoT device, but client app can still receive message from those IoT devices. So unauthorized message received by client app is shown in this picture. In this figure, it is shown that single client device receives multiple notification messages from a IoT device for a single generated event. Suppose a single device supports multiple accounts for registering with a single IoT device. Client 1 device registered 3 accounts with a single IoT device ID1. A same client device refresh token value is same T1 if device IT device ID1 generates an event. Cloud table inside cloud server finds 3 row with different account ID but same account same client device ID and token value. So cloud sends 3 messages to cloud push service with token value. So T1 token value T1, then CloudPush service delivers 3 push messages to client 1 for a single IoT device event. Client app is receiving 3 push messages through cloud. This is an issue in our proposed IoT push notification framework. If client app and same IoT device register for multiple times in cloud somehow, then multiple cloud tables row can be inserted as shown in this figure. So client 1 register with an IoT device ID1 in cloud twice. That's why 2 rows are inserted in cloud table with an account at the rate of Gmail and token T1. Suppose ID1 generates an event, cloud scans cloud table with value ID1 and send 2 event messages with token T1 to cloud push service. Then cloud push service send 2 push notification message to client 1 as token T1 is associated with client device. So our naive approach of this solution can be remove all other records related to client app device except currently login account row just added in the cloud table. We solve CloudPush framework vulnerabilities by encrypting notification message data and implementing in cloud database layer by checking with currently active client account ID. Cloud encrypts notification message data using a key generated using the algorithm tree shown here and shared the key with corresponding client application. When client application receives the encrypted message from cloud, it decrypts the message using the key. As the key is generated based on account ID and client device ID, it is not possible for other devices to extract the unauthorized message. We prevent unnecessary and unauthorized notification message sending to client side by keeping track of active client ID in cloud. We keep another column into the cloud table that maintains which one is currently logging. So which one is currently login when an event is generated by the IT device and the event is sent to cloud. Current account column in the cloud table is checked with corresponding client device ID. Only current account Y related to client device get notification if relevant IT device generates an event. In the first table, client 1 registered with ID 1 and 3 accounts. Suppose b1@gmail.com is the current login ID. ID1 generates an event and sends its event to cloud. Cloud finds ID1's corresponding row by checking current account column Y and sends one notification message to client application client 1. So the problem of receiving multiple messages is solved here. In the second table, client 1 registered with two different IT device ID1 and ID2 with two different accounts, a1@gmail.com and b1@gmail.com. b1@gmail.com is currently login and bounded with ID2. If ID1 generates an event, there is no login account exists in the cloud database, hence no notification message is sent to client 1. Thus current account column solves unauthorized message receiving problem 2. To prevent creating a similar row for multiple times, we use unique client ID instead of random device ID. This will ensure that same client device with same account ID and same IoT device ID cannot be registered more than once. We apply optimized runtime searching algorithm in cloud that find any component from cloud device in order of almost 1. This is order of 1 time complexity. In this is actually the optimized try solution. In CloudPush framework, search item can be client device ID, account ID, IoT device ID. These three items are indexed in a search tree. A search tree is formed in this figure based on the cloud table using these three search item. Leaf of the tree contains a object associated with the cloud table row. When an item is searched from the tree, it can easily retrieve the corresponding row of the cloud table. It saves a significant amount of time while querying and improves throughput of CloudPush framework. We set up an experimental testbed consisting of an Android client application, virtual IoT device implemented in an Android IoT framework, Amazon Cloud, DynamoDB, and Firebase Cloud Messaging. In this setup, we deal with a different number of client application device and software implemented virtual IoT devices that send notification message to client application through the Amazon Cloud. Amazon Cloud holds Cloud Table and FCM work as an CloudPush notification. Performance comparison between CloudPush framework and IoT framework. There are two variants. One, number of events generated by IoT device, and number two is number of client application device received messages are considered while comparing aggregated throughput between CloudPush framework and IoT framework. We observe that overall execution time of an IoT device generated events in CloudPush framework is uh, 12 to 15% better than IoT framework shown in this picture. In this experiment, one IoT generates all the events and the client application receives all of the events. So overall execution time increases if number of events generated by the IoT device increases for both framework. If we vary both number of events generated by IoT devices and number of notification message receivers, then performance of CloudPush framework increases to 12 to 15% shown in this figure. Events are distributed among client application in this experiment. Each IoT device generates equal number of events, and these events are received by equal number of client applications. CloudPush framework performs better because we use separate cloud server and CloudPush service layer that can be scaled up depending on number of events requested by IT device and number of client application device involved with events during execution time, and run optimized searching algorithm in the cloud server. After applying notification message encryption solution in CloudPush framework, it is observed that system performance is reduced to 3 to 5% without uh, compared to without encrypted notification message in CloudPush framework shown in this figure. Notification message is encrypted for a secured multi-user support, but it makes existing CloudPush framework with raw message 3 to 5% slower, but performs 9 to 12% better than IoT framework for a single client. If events are distributed among multiple clients, then performance improves about 9 to 23% than IoT frameworks. Overall aggregated event processing time comparison among CloudPush system encrypted and non-encrypted notifications and IoT framework is shown in this figure. It is shown that without message encryption, CloudPush throughput is better than encrypted message in CloudPush and IoT framework. Even applying message encryption in CloudPush framework, throughput is better than IoT framework. So concerns have been raised that new IT platforms are being developed rapidly, and the profound security challenges involved in these IT environments are not taken into appropriate consideration. We introduced a push messaging framework named CloudPush for IT environment with multi-user support, and discuss the vulnerabilities of the framework and their countermeasures. The aggregated throughput of CloudPush framework is better than IoT framework, and Cloud server and CloudPush service layer are separated that can be scaled up the system and depending on number of events requested by IoT device and number of client application device involved with the events. Moreover, the Cloud runs optimized searching algorithm on cloud database records. Notification message is encrypted and tracking current client account ID in a cloud for a secured multi-user support. Finally, the CloudPush framework is significant in the field of IoT ecosystem as it supports secured multi-user feature. And for future work, we will solve D2D communication, device-to-device communication in a multi-user system. These are the references. So thank you very much for listening to this talk, and please do let me know to my email if you have any query. Thank you so much for your time.